All right, Foundations Pre-Cal 10. Here we go. This is video 9, but this is video 1 from section 3. So we are now looking at the three forms of linear equations. So we're looking at only straight lines again. We've already seen the linear equation in 2 forms, so we're going to look at 3 now with a slight adaptation on a couple of them. So first 2, we've already seen one of them, okay? We have what's called standard form. And we've looked at standard form before, right? It's in the form of ax plus by equals c. The x and the y are on the same side of the equation. We didn't love this one, but it had its benefits. And then it equals our number, right? Now, a, b, and c need to be integers, which means there are no fractions to technically be in standard form. But then the big one is a needs to be positive. So if we want to narrow down our number systems, a actually needs to be a whole number. So in this case, we have 2x plus 3y equals 6, right? None of those numbers are fractions, and the leading term here is not negative. So that is technically in standard form. What we're going to look at now, and what you're going to see more often than not moving forward, though, is what's called general form, where you get everything on the same side of the equal sign, and you just get it equal to 0. Now, one thing you'll notice is here it says plus c, and then in the question down below, we have a -6. And you might be thinking, well, that's not plus. But it's important to understand that -6 just means plus -6, right? So in this case, your a term is a 2, your b term is a 3, and your c term is a -6. So you're still adding c, but we just write it obviously as minus c, so be okay with that. The only place you're not allowed to see a negative again is in front of the 2. Now, you could have a negative in front of that too, and it exists, but it's technically not in general form. Having things equal to 0 is going to become really handy, and we'll talk about that more in the sections and years ahead. Okay, so standard and general. So here we go, we got a couple equations. We want to convert them both into standard and general form. Now the first one here looks really close. It's like, well, that's almost standard form, and it is. The only problem is I don't like this negative here. So how can you get rid of a negative sign? Well, you can multiply the entire equation by -1. So multiply that, multiply that, multiply that. Since it's equals and we're multiplying everything, it doesn't change the equation, it just changes its appearance. So we end up with positive 3x, but then minus y equals -4. All that's allowed in standard form because our leading term is positive. So that's a quick shift. And then how do we get that to general form? Well, we do one slight piece of algebra. We just add 4 to both sides. So then our general form is 3x minus y plus 4 equals 0. So there's standard form there. And then that's general form there. It's just one extra adaptation to standard form. So now if we look at the next one, we got a bit of a problem because we have 2/3 and we don't want a fraction. So in this case, we're going to have to multiply the entire equation by the lowest common denominator, which is 3. And what we end up with is 3 into there, into there, and into there. We get 2x plus 6y equals 9. And there it is. There's my standard form. So how do I get to general form? Well, I just subtract 9 from both sides, and my general form is 2x plus 6y minus 9 equals 0, and that is my general form. So it's all about algebra at this point. So we're going back to grade 9 algebra we use all the time in order to convert equations into what we want them to look like, because we're going to see a connection here between all 3 of these equations. So the next equation, so that's standard and general kind of count as one equation in the 3 linear equations conversation. And then we got our bread and butter, slope-intercept form, right? So we got y equals mx plus b. We hammered this home in grade 9 and a little bit in section 2. B is the y-intercept. So here, right, -4, that means my line goes through right here at -4, y-intercept. And slope is the m value. So in this case, here's my slope, and it's rise over run, which means I go up 3 for every 5 I go over. So I would go up 3, and there's my next point, right? Up 3 over 5. And I can graph my line. Slope-intercept form is our favorite because it gives us that information right off the bat. So here we have an equation. It's not in slope-intercept form. We want it to look like slope-intercept form, which means we need the y value all alone. we get y all alone, you're in slope-intercept form. So first thing we're going to do here is we're going to do some algebra. We're going to add 2x to both sides because we want to get rid of the 2x. So now you have negative 3y equals 2x plus 12. Now I'm almost there, but I don't want that negative 3 there. So I'm going to divide by negative 3, but then I have to divide by negative 3 and divide by negative 3. I have to do everything. So what do I end up with, right? Cancel, cancel, I get y equals, that's a good start, negative 2 over 3x minus 4, because plus, positive divided by negative. So what does that give us? That gives us negative 4. And if you're wondering why I keep getting a streak on the corners, because I'm left-handed, and my pinky knuckle keeps touching the screen. It's quite annoying. And then my slope is negative, which means I can either go down to negative 2 and positive 3 to my next point, or I can go up to, but then negative 3, which just puts my negative in the denominator, because negative 2 over 3 is the same as 2 over negative 3. And there, obviously not the staircase, but there is my line. You would use a ruler. I don't have one. But converting to slope-intercept form is helpful because it's the easiest equation to graph. We can graph because we know the y-intercept and we know the slope. So here's another one. Well, again, we want y alone. So first thing we're going to do is subtract 3x and subtract 3x. So now we have 2y equals negative 3x plus 12. And then we are going to divide by 2, divide by 2, divide by 2. And we get y equals negative 3 over 2x plus 6. So we're up here at plus 6. Up here at plus 6, and we are going to go down 1, 2, 3 over 2. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. Now you can see why I made a big fuss about making sure we can graph linear equations. Whoa, that's not very linear, because we're going to need to do it over and over again, and that is why you use a ruler. Okay, now what about if you're only given a point and the slope? Well, the good news is we can use slope-intercept form and tie it to the fact that we don't know the y-intercept, but we know a point. And remember that any point that exists on my line can be subbed in for that xy. So in order to figure out my y-intercept, we just sub in negative 4 for y and negative 2 for x, because that's what this tells us. This tells us that when x is negative 2, y is negative 4, and it exists on this line. Because then we can solve for b. We get negative 4 equals 6 plus b, subtract 6 from both sides, and we get negative 10 equals b. So what that tells you then is that tells you that, if you, negative 6, and if we have negative 6, then we are adding 6 to both sides, and we get b equals 2. That's better. So what that tells us is we have a y-intercept at 2, because we've solved for that now, and then you know the slope, so now you can just start sloping. Up 3 over 1, up 3 over 1, or down a negative. And there's your line. So you can plug a point in to solve for the y-intercept, and then you can graph your line. So it's a handy aspect of slope-intercept form. But we have this whole other equation that's going to help us with it. So let's do one more of these. So we can use this slope and this point to determine the equation in slope-intercept form again, right? So we have y equals, well, what's my slope? 2x plus b. Don't know b. But I can sub in negative 4 here, and I could sub in 1 here, and then I could solve for b. So I have 1 equals 2 times negative 4 plus b. So 1 equals negative 8. Now I'm going to screw this one up, and I'm going to add 8 to both sides, and I get b equals 9, which then tells me that I can complete my equation by saying y equals 2x plus 9. So you can determine the equation of a line given that information using slope-intercept form, but you can also use this brand new equation we have called point-slope form. It's called point-slope form because we're using a point and a slope. So the m in this equation is still your slope. But in this case, and if you look at standard form, I'm going to digress for a sec. If you look at standard form, ax plus by equals c, or general, right? And then you look at slope-intercept form, there's always an x and a y in your equation. So for point slope form, we need an x and a y as well. And we have that. Let me just make a bit of a typo here. We'll call this, here, I'm going to work a bit of magic. I'm going to cover that up. And we're just going to write in x, just so it doesn't say x2, okay? Because it's x minus x1. Because the thing to identify is that this y and this x are not going to leave the equation, because we need an equation to finish with a y and an x in it. If we consider our point, we're going to have a point x1, y1. It's our one point, and that's what's going to sub in here and here. So I got this lovely feeling that I'm going to have a typo in all of my equations, but we'll just use it the way we know how to use it. So here's how it works. Yeah, see, forget about this. It's just an x, not x2. Okay, so we have a slope of 2, so identify the fact that we have m equals 2, and we have a point. So we got x1 is -4, and we got y1 is 1. So we sub that into our equation, and the goal here is to end up in slope-intercept form. Now you could argue I could just use slope-intercept form, and you can, but might as well have as many little tools in your tool belt as possible. So we sub it in. So we have y minus y1, which is 1, equals m, which is 2, times x minus x1, so be careful here, -4. We are minusing x1, and since x1 is a negative, we got to write it in like that. So then we get y minus 1 equals 2 times x plus 4. We are almost there. Water bomb the 2 in. Y minus 1 equals 2x plus 8. So now we're really close to slope-intercept form. We just need the y alone, so add 1, and you can see we end up with y equals 2x plus 9. Now what you'll notice is, there we used point slope form, back here we used slope-intercept form, and we got the same result. And we should get the same result, it's the same scenario, just another way to get to it. So we got one more here, except this time we're going into standard form. So we've got a little bit more algebra, and again, remember this isn't an x2, it's just x minus x1. So here we go. We have, you can identify my x1 point is a 3, my y1 point is a -2, and my m in this case is a 4/5. So I have y minus -2 equals 4/5, and then x minus x1, which is 3. So now algebra, y plus 2, because a negative minusing a negative is plus, and then multiply this into here. So now we have 4/5x minus 12/5. And now we're going into standard form. So a few things to do here. You can look at this a number of different ways. You're going to have to rearrange so you have the x and the y together, but we also don't want fractions. And if you look at this entire statement, and this will just get rid of the fractions early for you, what's the lowest common denominator? A 5. So multiply everything by 5. Okay, multiply it into here, and into here, and into here, and into here, because it's going to get rid of your denominators. What you're going to have, you're going to have 5y plus 10 equals 4x minus 12, because the 5 cancels with the denominator here and here. That was why we multiplied by 5. And now we're close. It's also helpful to remember that you want your x value to be positive in standard form, and it's positive here. So let's keep it on that side of the equal sign. If you have x equals 5, that's no different than 5 equals x. We're just really used to seeing the x on the left. But it doesn't matter, right? So all we need to do is get rid of this 5y. So let's go minus 5y minus 5y. And now we have 10 equals 4x minus 5y minus 12. So we're almost in standard form. We just don't need this -12 over here. So we're going to add 12, and we're going to add 12. And what do we get? We get 22 equals 4x minus 5y. Now you could be looking at that saying, that is not slope-intercept form. What am I looking at? And the thing is, that is not standard form. What am I looking at? You are looking at standard form. You're just looking at standard form in the form of backwards equation. It's 4x minus 5y equals 22. No different than the one above. Okay, that are the three forms of the equations. We're going to manipulate them a lot, move back and forth. So far, so good. Keep it up. You're doing awesome.